So I'm going to demonstrate my cloud computing project. So my project is about location-based crime data search and analysis with Spark user-defined functions. So this is the overview of our project. So it is about like I'm having basically three major components. One is this Swagger service, crime Swagger service, and other one is the Spark user-defined functions, which is of course doing map reduce on the data. And other one is Flask web application. So in this web application, we have one particular user who will normally search through the website, and this admin so these are not secured, so those are open for anyone, but these admin functions like updating the data source, I mean updating the data files and downloading the data files, those are secured with basic authentication. And of course this admin person can trigger the Spark user defined functions to do the map reduction after he has had finished downloading the data source. This project is about the crime data analysis. This is the crime data is downloaded from this data.government website, which is the data set is about crime data from 2001 to present date in Chicago City. So this map reduced based data is can be used by user, and it is done for the entire data set. But these other functions like find nearby crimes for a radius and get plots for nearby crimes, those are for 1% of the total data. I will explain the web project I have come up with. That means that I will explain these services with the Flask web application I have created. So this is the overview of the project, and if you see, this is the interface and web interface I have come up with. So this is the Flask web application, and of course this is this uses Google JavaScript API, and I have coded all these functionalities. So what user can do is basically first of all he can, I mean since this data is about Chicago City, we can generalize this for the entire country if we have a data set. But like for this project I'm explaining it for Chicago City. So even without searching anything, he can see the map reduced data, and you can see there are three plots like map reduced by time, and this is the time series analysis in the green color, and this blue color represent the total arrested, I mean arrested crime count for one particular month. So you can zoom in to see this particular location, and then you can unzoom using this unzoom button, and there's a clearly a trend here. So if you are planning to visit Chicago, I would suggest you to visit in between around, let's say, from February to uh, February to maybe June, July. So that would be the best time. So from all these values are representing those months from February to July. So these peaks are representing somewhat year-end months like October, November, December. So there's a clearly pattern here. So the trending is like total crimes are going down, but we can see the total arrested count versus the reported crimes are like uh, arrested is like much lower than the reported crime. So there's a, I mean those are not solved, at least we can say that. So and other than that, so here this is the uh, total crimes reduced by using the time types. So the uh, the most so this the highest crime reported is theft, and so here you can see it by looking uh, so if you zoom this, so this is like straight, so the least safest location would be a straight to go on, and you can unzoom these graphs to see more. And like after that, what you can do is you can hide this, and then of course, you want to, so let's say a user is going to buy a house in Chicago. So he has to search his vicinity, and he has to know about is it safe to buy a house in this region. So let's say he's going to search with 0.1 mile radius, and let's say his address would be like Chicago or the center of Chicago. So then it will automatically download, I mean analyze the data in the Chugga service, and it will the response will be shown in this web interface. If you close here, here is your search location, and these are the reported crimes nearby. This is based on 1% of the total data set, and selected this 1% is selected randomly. And you can hide markers, like you can see one by one, and you can see this one by one, and of course you can hide markers again, and you can go into cluster mode. Then you can see it's like in cluster modes, you can see through how many crimes happened in that particular area. Of course, I have to tell you that you can turn off the cluster mode and then show the markers again, and uh, you can unzoom. So as this data set is actually prepared by Chicago police, and for privacy reasons they have uh, the latitude and longitude. That means the location of the crime is estimated to the nearest block level, so that is why it is showing us this one thick line. But if you increase the radius, you will see, like let's see, if we go for 100 miles, it would be high. I think there will be too many crimes. Let's go for like 50 miles, and let's change the address, like let's say Chinatown in Chicago. Now it's searching for that particular location, and the vicinity area would be like 50 miles radius. And it will take some time because there are many crimes. So this 1% is also like I think it's 200,000 of rows. So the dataset is totally around 1.5 GB, and it is yet I mean it is constantly updating, and it will grow. And this should be coming any second now, because from my experiment is it's usually takes around for 50 miles radius, it takes around 30 to 40 seconds. And so let's wait until it arrives. Let's wait, because it's taking so much time. Okay, it has arrived. Now it is populating the now it is populating all the drop points in the map. So you will see a lot of drop points are here, because there are too much data. So you will see. So if this is not real helpful in this form, right? Like there are many drop points you cannot see, I mean uh, it one by one. So this is like a lot of data. So if you click this one point, it will there's a nice animation going on to show you that this is the point you have clicked, and you can get an information window pane for that particular crime. And of course what you can do is in this mode, so you're going for larger area, so you should actually turn off hide the markers, and you should go with if you hit hide markers, it should remove all the markers from the map, and then it will you should enable this show clusters, and it will nicely show you the clusters in that particular area. So you see nice so this red implicating that it is really high, that crime rate is high in that area, and yellow is low. So you can get nice idea about that. Other than that, what you can do is you can go into graphs, and you can analyze this area you have selected. Like this is showing the total entire data set on entire Chicago city. So what if you click this button, analyze search result, and it will pop up nice two graphs actually. So this is plotting top 10 crimes near reduced by month, and this is top 10 crimes uh, near you, I mean near the location you have searched, by the year. So if you search for, let's say if we go for 2018, so the most reported crime is theft, and then criminal damage, and it goes on. So it's like that. So and even you can search in this time series graph. So you see, so and you can unzoom the graphs to unzoom it, and then you can hide it, and you can search. So this is pretty much about it. So if you are interested about one crime, you can uh, hide the clusters, and only see, let's say we are interested about theft, you can search only theft. There are a lot of theft reported crimes. So that's about it. Thanks for listening.